This video will demonstrate the benefit of eDesignSYNC in design optimization by using eDesignSYNC on a simple connector model. The first step is to open the connector model in SOLIDWORKS and launch Moldex3D eDesignSYNC. Click Part in Tree menu and choose a solid geometry as part. After that, we have to choose a material. In this case, the material type is going to be LCP, and users can choose different producers and grades in this window. Click OK to finish this step. Next, double-click Runner in Tree menu to define Runner. Select this solid model in the screen as Cold Runner. Now the solid model is attributed as a Cold Runner. A melt entrance is also a necessary element for injection molding analysis. The melt entrance tells the software where the plastic will start to flow from. We need to select the top surface of the Cold Runner as a melt entrance. In eDesignSYNC, Moldex3D provides automatic mold base building. We can use this function to auto-generate a mold base. Then we set the mold base metal material by default. Before we start the analysis, we have to set the simulation sequence, process conditions, mesh level, project saving path, and report format in this window. Then click Analyze Now to start the analysis. After the analysis has finished, we go to Check Results. In filling analysis results, we check the flow pattern from the melt front time result. It shows obvious racetrack effects in the filling animation. The racetrack effect leads to unbalanced filling and may cause uneven volume shrinkage, air trap, and weld line in the part. If we watch the animation again, we can see the air trap and weld line indeed exist in this flow simulation. The racetrack effect can be solved in several different ways. For this part, we will decrease the thickness on one side of the part to balance the flow. We use several CAD tools in SOLIDWORKS to cut a slot on this side of the wall. We want to analyze the modified model to confirm the design change is effective. For comparison, the analysis setup is the same as the original one. Let's examine the results of the revised model. We find out that the flow pattern of melt front is more balanced than the original one. The melt front evenly reaches the end of the cavity almost at the same time. Because of the balanced flow behavior, the revised model shrinkage is more even than the original design. There are 4 parts in this video. Perform an injection molding analysis for original connector model. Examine the analysis for the original connector model. After the analysis has finished, we go to Check Result. Modify the geometry to improve the unbalanced flow and warpage. Examine the result of the revised model. Moldex3D eDesignSYNC is an easy-to-use interface embedded in SOLIDWORKS to bring a seamless workflow from design to simulation. With the complete support of Moldex3D eDesign, designers are able to synchronize design changes and verify product designs with professional injection molding simulations in order to solve design and manufacturing difficulties more efficiently in a familiar environment. The integration between design and simulation creates a high-performance design platform that gives designers the ability to examine, optimize, and seamlessly create mold designs. Finally, it enhances product quality and reduces cost through eDesignSYNC for SOLIDWORKS.